So, good afternoon. Good afternoon.
Good afternoon, ma'am.
Ma'am.
Yeah. So I request you all to keep a book and pen so that we can note down some of the points because today we have some calculations to work on, which will help you if you calculate.
Okay, ma'am.
Okay, because the next two units, what we are going to do are little lengthy. So I will start off the class because that's where I thought I'll log in early so that I'll take up the whole thing before 4:30. Okay, so let me start the class. We have unit 6. Yesterday, we have completed about Unit 5, where we were learning about the memory techniques as well as what is inside the computers. So today, we are learning completely what is inside the computers. Inside the computers means starting from motherboard to the box and the ports, the extension slots, the ribbons, and memory chips, processors, all these things. There are several things that are inside the CPU. So we are looking for what is there inside the CPU. So throughout our first few units, what we have completed is to understand what are the different components of the computer, how it works, what are the memory, short term, long term, DRAM, SRAM, RAM, ROM, or types of SRAM, types of DRAM, all those things we have learned in the last classes. So now we are going to learn what are inside the components of the CPU. So here we have the computer cabinet we call, and from computer cabinet, we will go each and every part of the how the cabinet is, first of all, which type of cabinet is suitable for whom, how do we work on the cabinets, all those things we are going to work on. So inside the computer, we say define the form factor of computer hardware. We are going to understand what is the computer hardware. Hardware means the system, actually, right? And understand the computer cabinets, then various ports, what we connect to the computer, the wires and the other things, we call them as port. So that ports we are learning, the processors, whatever I told you yesterday, the capacitors and the other things are there. So the processor chips, motherboards, and memory chips, all those things we are learning in this. So if you go into the computer and just you can, if you have a desktop or anything, you can open. There is nothing, don't touch anything inside part of it. You just open the screws and then you can just work with it. Actually, learning those how the hardware is working helps you a lot to understand about the computer because like our body parts, how our body parts are, each and everything we need to understand how the blood flows, where from where to where, how it is working. All those things will help us to understand how we take care of our body parts. Same manner for the computer. How, if you know all the parts, where are what parts, it will help you to monitor or do work with that properly. So shape and dimensions of computer hardware such as cabinets, motherboard is decided by the form factor. Form, what is the form you want to have? Horizontal, vertical, tall, short, mid, any type of things. What type of form factor you are looking? Those things we need to. So we will define and explain the form factor later on in the next classes. The SMPS unit is very important component of the computer. SMPS, we will learn about the SMPS values. Then we have the AC current and DC current. AC current is what is coming from there, and DC current it is converting the current it checks for the fluctuations that are coming from outside, and then it puts it into the direct current for us so that the system does not get damaged. Then computer motherboard will supply required digital voltage in order to generate stream of discrete pulses. slowly one after the other, the signals will be given as 0 and 1. Remember, it works on the binary code 0 and 1, which is called as digital signals or digital electronics. The computer motherboard will supply required digital voltage in order to generate, say this part, in order to generate the signals. So, which is called the digital signals or digital electronics. Computer motherboard has provision for various third-party devices such as weather forecasting, satellite data analysis, temperature monitoring. You get in the corner time, all those other things, whatever you want, you will get the information. Now, let's see what are the different forms of computers. These are the different forms of computers. We call as full tower, mid tower, mini tower, SFF, small form factor. So these are the different types of form factors of computers. Each one is based on the compatibility, shape, size, look, all those things. And inside you have different slots to keep motherboard, to keep the capacitors, to keep the everything. You can have different slots. So this is it is defined mathematically as the ratio between the length, height, and breadth of the real world objects, such as computer hardware, electronic circuits, mobile phones, tablets, etc. Form factor we call. So these based on the form factor, how much shape size you want, that based on that we will call as the form factor. Full tower, mid tower, mini tower, small tower, all those things. So these are the different forms of computer. Then we have ATX desktop, ATX bench case, ATX mini tower. So these are the different forms of we call. ATX desktop is the standard one generally, and it holds the motherboard and with the ATX form factor. And these cases usually accommodate motherboards that keep the basic rare layout but reduce the size of the board. So here you can see the types of systems. ATX desktop. This is the huge form of ATX desktop. Here the motherboard slot will be there and other ports will be connected here. And you can see the different types of things. Everything there is a slot allotted for it. And then the things will get fixed into that. You start working on it. So this is called ATX desktop. And this is called ATX bench case and ATX mini tower. Here only generally we use this kind of things. These two are not anymore we are using. Nowadays we use maximum this type of things where we keep everything into one cabinet. All slots will work on this type of systems. Then these are also a few ones: ATX mid tower, ATX full tower, and ATX super tower. So these is high-end versions, whereas these are the mid tower and this type of things we use generally in the in our colleges or in our homes, etc., etc. Right? ATX mid tower, ATX things. Then we have home theater computer case. This is the general case. This is how it looks like. So home theater computer case, HTPC. It can be great addition to customer or home theater. You can put all your components or different components in the slots that are given to you. And there are windows for the air to flow, and there are ports that can be connected here. Same manner, server chases. But for servers to keep it, we'll have like this the ports. Then we have switch mode power supply, SMPS we call. Switch mode power supply, that is SMPS. SMPS is very important component of the computer system. Total power supply to motherboard and its components is supplied by SMPS. This is the main thing, which looks take care of your DC voltage or AC voltage. How much voltage is coming, whether to convert into AC to DC or keep it DC directly, or it is 110 volts or 220 volts, how much it is coming, how much power supply can be given. All those things can be checked with switch mode power supply concept. So SMPS we call. Mostly it looks like this. SMPS pin configuration. It looks like this, and these are the different ports that are connected, and all the wires will be connected inside with the to the slots here. Okay, so you can open and see them and understand how they really are getting connected. Types of SMPS or switch mode power supply. First one is the AC to DC. I told you from the outside, whatever voltage is coming, it is called generally AC current. So AC current that is coming is having different fluctuations. The modes will not be the same. So the voltage can be regulated or connected directly from converting from AC to DC. And then the power PFC we call it is power factor correction. So it uses that and then reduces the voltage, keeps the AC, I mean, keeps the computer work smoothly. Right, DC to DC converter. If it is DC, backend UPS or something else is there. So you DC to DC converter, primarily a high voltage DC power is directly obtained from DC power source. Then this high voltage DC power is switched at very high switching speed, 15 hertz to 50 megahertz it goes, right? Then we have flyback SMPS. Flyback SMPS is almost like less than 100 watts. It is very simple and low cost circuit compared to SMPS general circuits. So it is also desired output voltage by fast switching using MOSFET, this one, whose frequency is around 100 kilohertz. The step down transformer isolates the voltage. It reduces the voltage so that the system, the inner components are very delicate, so they don't get burnt off or they don't get switched off. So that's where it works. Flyback converter. Then forward converter, it is also like the switch, flyback converter only, but in this case the control is connected for the control is connected for controlling the switch, and at the output the secondary winding of the transformer and the rectification of filtering that can be added. I'll show you here. Yeah, so if you see inside your the computer CPU, you find one of the panel in this manner. This panel here, you can see all the ports are connected, outside ports that are connected, your camera or your microphones or capacitors, I mean, or all the peripherals, keyboard, mouse, printer, USB port, Ethernet, audio connections, all those things are here. Okay, and here this is the backup battery. Suppose in case the current goes from AC, generally you keep the connector power supply, you keep it. In case the power supply go, this gives the backup battery. It gives at least 10 to 15 minutes time, so that you can instead of getting switched off, you can save your files whatever you are working and protect your system. And same manner, PCI slot X5. So here this PCI slot X5 will make your system work smoothly. Then South Bridge AGP slot, then North Bridge. We will be learning all these things in the next line. So IDE converter, DRAM memory slot. Yesterday I explained you DRAM memory slot. This is the DRAM memory slot. Can you see this blue line? All the memory dynamic RAM. So all the dynamic RAM will be set here. Then 20 pin ATX power converter. So this power converter, it will convert AC to DC and then make it work smoothly. Then CPU fan and heat sink mounting points. So this the fan, CPU fan, it keeps the system cool, and inside it will rotate, make it cool. And this is the completely motherboard which works. Right. So the block diagram for the motherboard is very, very important for you for the exam. Computer motherboard. Here you can see the South Bridge and North Bridge. In this, I'll make it more bigger for you. So in the South Bridge, you have input output control. IO control means input output control. External port control hub. For everything, whatever is coming from external ports, that means your printer, mouse, input, you are giving from the keyboard, you are giving the inputs. From the mouse, you are giving the inputs. From the output, you see the monitor, the printer, all those things will get connected to the South Bridge. Then coming to the North Bridge, you have the memory, whatever dynamic RAM, SRAM, all those things will be in the north bridge, so that everything will be at one place and it gets stored properly. Then graphics, processor, control, all those things are in the north bridge. Then it will be connected to the graphics card slot, because if you want to work with the graphics, it has to get connected to the graphic card. Some special card will be there, which we call it as a graphic card. And from there, it takes the inputs into the graphics once and then give it to the storage. And memory bus. From here, the memory, whatever is coming from the input, goes to the memory slots, and then it gets stored, and then it is called the memory bus. That this will have the like a key. It will tell where the memory is. Suppose, for example, you kept your pen in some corner of the house. Where it is, you should only remember, right? So the place where it is, this north bridge will say. Then you have super IO, serial port, parallel port, floppy disk, keyboard, mouse, all those things will be connected to the super IO. And flash ROM. Here the BIOS flash ROM will be there. And here above, actually your front part, whatever is the front side of the CPU, you have the CPU clock generator, front side of the bus. This is how inside the inside the CPU it looks like. Then types of motherboards. There are two types of motherboards. One is called non-integrated and the second one is called integrated. In the good old days, we did not have motherboard, means only motherboard, which takes only the input output signals, process and gate. Whereas it is not today now. All maximum things are integrated within the computer, the board into the motherboard only, so that you don't need to keep separate things. For example, your laptops or the other things, they have all integrated ones only. We don't have non-integrated. Previously, the desktops used to have the non-integrated ones, because there is a separate place for the CD drive, separate space for the memory chips, separate space for everything. There is a separate space, and then that's where we call it as non-integrated. Whereas integrated means your IDE, serial ports, everything will be inside, and then they're all directly connected to the motherboard. That's called integrated and non-integrated motherboards. So here, see, integrated motherboard, how complex it looks. Everything will be one jam-packed, compact, like our high-tech city, very, very thick, very thickly populated type of things. Can you see? So many connections will be there to the motherboard. Everything is connected, and through motherboard only we get all the signals and importance. Whereas if you see it here, it is everything separated. You have a memory slot separately, your ports are separate, your RAMs are separate, your this thing is separate, everything, processor is separate you have, so that if at all one gets damaged, if anything goes wrong or anything gets damaged, only that part we can replace. So it is cost effective, non-integrated. Whereas integrated, if one goes wrong, the whole thing we have to replace. It becomes very difficult. Of course, they don't go wrong, but sometimes if we have more high voltage or any virus into the system, anything gets damaged, in the integrated motherboards we have to remove everything and replace it. Whereas in the non-integrated, we can replace them whatever is possible. Then we have motherboard form factor. And what is the motherboard form factor? The determines the general layout, component placement, size, feature placement, power supply connectors, etc. on the motherboard. Where are you keeping those for everything? See, in your house, kitchen place is separate, bedroom place is separate, or TV slot is separate, sofa slot is separate. Everything in the house only you have different. But when you see from outside, it looks like four walls. Correct. Same manner, the motherboard, the CPU inside, it looks like this thing, but inside everything has a separate place. The component placement, layout, where it is, how the size, the feature, the power supply, where it has to be, the memory where it has to be, everything will have its own places. Essentially, there are 8 types of form factors available for motherboard in the market. 8 types are there. Lot, depending on what is your requirement. 2 bedroom, 3 bedroom, 1 bedroom, 0 bedroom, whatever you like, shared bedrooms, anything. So at the advanced 80, that means advanced technology, it is the oldest and biggest form factor and popular until baby 80, capable of using 386 processor, that is 12-inch size, and was difficult to install, service and upgrade. 8 advanced technology, that is the oldest one but difficult to upgrade. It has all the maximum features in it. Then baby 80, that means baby advanced technology form computer, a standard computer industries and still being used in premium class products. CPU socket is placed in such a way that it can interface with the longer bus cards. It has the limitation of peripheral cards installation. Input output ports are connected to pin outs near the floppy drive, which results in jumbling of the ribbon cables. So everything will be connected, baby 80, so small size, but definitely it is really not advanced technology is only used. Then ATX advanced technology extended ATX means. So the improvement is done in easy to use, support for current and future input output, and also to current future technology. You can use this ATX advanced technology extended. Most of our if you remember in the front cases, I told ATX desktop, ATX midware. So these are all ATX advanced technology extended. These are the ones what we are using as the as the cases. Right now, EATX, ATX, micro ATX, mini ATX. See the kind of robustness or kind of the components that are integrated into that system. Very, 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 very each and every minute thing which makes the computer work at the back end. Will not know only how it is working. Then mini ATX, micro ATX, flex ATX, LPX, low profile extension, and NLX, new low profile extended. So these are the different types of ATX that are working. The mini, micro, flex ATX, and LPX, right? So what is happening, Akhila? Why are you doing it? Akhila, erase them. Who is the people who are doing the red lines and blue lines? Are you all grown-ups or small kids? Hello. Behaving like LKG children. They are much better than you people. Why do you need to draw the lines? People don't understand, right? I'll remove you if you are behaving like this from the class. Next one. So components and layout of components and layout of the motherboard. A typical ATX motherboard, we will have ATX, as you know, for that particular thing, advanced technology extended PC. Who is doing it? It is live streamed. Are you understanding?
Yes, ma'am.
Hello? Who is doing it? Who is making it? Behave yourself, children. So now we have the next one. Components and layout of motherboard. So a typical ATX PC motherboard with the constituent components are given below. The port we call, port means where it is getting connected. So a port is a physical interfacing where can you see the screen, all of you?
Yes, ma'am.
Anyone
Yes,
can
ma'am.
see the screen?
Yes, ma'am.
Yeah. So a port is the one where we connect it, the wire and there are a few like this it looks. Yeah. So you can see these are some of the ports will look like this. Did you ever see the wires that are connected? Each one will be of the different types. So there are pins to that. Pin 1 is for data, 2 for no connection, 3 for ground, 4, 5 volts, 5 clocks, and then 6 is no connection. So this is the description of the pin out female port. This is called the port we call. If you see carefully, you will find these things in the connection. 6 pin, 5 pin port will be there. Okay. Then there are some more ports, serial port. Can you see, did you see this kind of things at the back of the TV or at the back of the computer? You find
Yes,
this
ma'am.
type of thing, serial port. The pin will look like trapezium. Top one flat, down one flat, and the number of pins that will be there. And these are the games ports, parallel port and games port, PS2 port. So these are some of the things what you see which are connected to the motherboard. Then we have parallel port. Parallel port are or Centronics 36 pin port. The Centronics are standard mode has 8 bits out of and 4 bits into the computer port parallel. Enhanced parallel port, that is 8 bits in input output to the computer port parallelly. Then these are the ports. I'll give you vector graphics adapter, VGA port. This is how it looks. The other 2 pins also you need to connect it to that and then fix it. You will have the screws. With the screws you have to connect. That is called VGA port. This one. Then video port. Previously we used to connect. There will be a video recorder or video play. VCD player, those things also used to be there. So for them, you will have one port like this. So these are the different types of ports what we have. So VGA port, vector graphics adapter, that is, or SVGA we call super VGA. So this VGA port is found in many computers, projectors, video cards, and high definition TVs. Even for high definition TVs, if you want to connect to anything, you will have the VGA ports. Then we have digital video interface. Digital video interface is the DVI. It is a high-speed digital interface between a display controller like a computer and display device like monitor. It was developed with an aim of transmitting losses digital video signals and replace the analog. Sometimes whatever we are transforming and then transmitting, we may lose some of the information. So it will be converted into analog VGA and then it will be displayed. So DVI, DVID, DVIA, DVII is a device port with integrated analog and digital signals. This is how it looks at the back. Then micro DVI, you will have micro DVI. You might have seen this type of things, video display, RCA connectors, where you will have the audio, video, and all those things. This is called RCA connector, and this is the videographic VGA port.
लाइना कौन मार रहे हो?
it will be difficult, children, to continue the class if you behave in this manner. It is not acceptable at all. What page number you are asking? Kruti? Who is drawing this? Please don't waste your time and my time. It's important for me to complete it. Then RCA connector, we have the continuity will be lost if I keep on giving the breaks. Others also don't understand. If you don't understand or if you don't know, leave it. No problem. Let others understand and then do it. So if you see carefully, we have the video display port. This is how the video display. If you want to connect your camera to that or video camera to that or laptop to that or any external device you want to connect. Suppose for example, nowadays it is pen drives, but previously we used to have the VCD players. So through VCD players, if you want to connect, you will have this kind of ports. Today we have with the laptops, many of the things have gone. We just work easily. Then comes RCA connector, Radio Corporation of America, we call, designed the cable connector. This connector can carry composite video and stereo audio signals over the 3 cables. Only 3 cables will be kept, and those 3 cables it takes the input data and then start working on. Then S video port and HDMI port. Today, most of the concepts we work with high definition media interface, HDMI we call. Your televisions are with HDMI, your laptops are with HDMI, HD TVs are there, Blu-ray players are there. Then these are all what means high definition. That means your picture clarity will be more good, audio clarity will be more good, no noise will be there. I mean, voice cancellations can be taken up and it works very, very wonderfully. So HDMI port, S video port. S video port is mostly used for video signals and it gives better picture quality than the previous ones. So most important are the S video port and HDMI port. If you see the HDMI port, it has 19 pins. Can you see? The connector consists of 19 pins and the latest version of HDMI, that is 2.0, can carry digital video signal up to the resolution of 4096. Can you see this? 4096 by 2160 pixels resolution, high resolutions, and 32 audio channels. 32, if you put into different channels, I mean, not TV channel type, audios, based on the frequencies. So based on the frequencies up to 32 audio channels, it can segregate and then record. Then we have USB port. If at all you have a USB where you want to connect to the USB means external port, whatever you are connecting, so that your network will come or your network. You can connect to internet. That's what I mean to say. So your internet and other things can be connected through the USB port. Like this, it looks. You might have done with the internet connection to the laptop or to the desktops. Did you see this type of ports? Where it will be like this inside. Then we have USB-C type port. This is C type port. This is one type where it is called the reversible connector. USB type or C type supposed to replace types A and B and is considered as future proof. The port of USB type C consists of 24 pins. Can you see the 24 pins? Top 12 and down also 12. So total together 24 pins will be there. The printout diagram of USB type C is shown below. USB type C can handle a current of 3 amps. 3 amps. amps it can take up. This feature of handling high current is used in the latest charging technology where a smartphone's battery will reach its full charge in very less time. So this type of ports, USB-C type ports will be used. Then we have RJ Ethernet. This type of Ethernet connections, you might have seen while connecting that wire to the internet in your houses. If you are connecting anything to the internet, you find RJ45. This type of connectors. So this type of
Yes, ma'am.
connectors connect the LAN or the internet to the system, right? So networking technology that is used to connect your computer to the internet and communicate with other computers or networking devices. You can once you are connected, you can make video calls, you can make audio, you can do Zoom class, you can do anything. This is the network connection we do. Whereas in the mobile phones, we have the hotspot where it gets connected or Wi-Fi directly into that. Then this is RJ11. We have RJ45 is this type. RJ11 will be of this type, Ethernet connection. This is generally from where outside your internet is
excuse me,
coming.
Hello.
That box, this type of system will be there, Ethernet connection and modem connection. Then you have eSTATA interface. eSTATA interface is where all your advanced technology attachments, external attachments will be connected and the ports are connected to the USB. eSTATA we call. Then small computer system interface, that means SCSI, is a set of American National Standards Institute, ANSI we call, is electronics interface that allow personal computers to communicate with peripheral hardware. So most of our things are most of our systems are peripheral, small systems only we have, not like previous good old days where the systems are so big, so huge, and we don't use such type of monitors or such type of systems. We have all compact systems nowadays. Even even your desktops also, they are very, very small and compact. So to that only the CD-ROM drive, CD writers or ATAC, STATA, all those are connected to that only, small computer interface. Then power connector, this is how the power connector will be there. Then expansion slots in the motherboard, we can have extra if you want to put 2 CD drives to the system or 2 DVD drives you want to put or more other things you want to put, we can connect to that, giving extra ports. Then we have, this is the PCI X card connector. PCIX card connector is peripheral component interconnect. These are the slots which we call it as a computer bus. Bus means here all the memory slots will be stored at one place. I showed you in the beginning. There is a separate slot where memory is there. So from there, so from in the beginning, I showed you where the memory slots are there. You remember one of the picture I showed you? Yes, here. So these are the memory slots. So this memory bus, I gave you this memory bus. So this is where the PCIs will be working, external slots, external component slots. Right. So PCIX card connector and PCIX slot will be there. So here the external components will get connected, and external components when hard disks or other things, external things, when you connect it, it starts reading what is the input and then gives you the needed output. The network or hard disk controllers, PCIX slots can mainly be found on special server main boards. The maximum bus clock of a clock is 133 megahertz, and those slots are supported by 3.3 volt signal levels only. So these are the types of signals: PCIe, PCIe. All different terminology will be there. Then industry standards, these are the architecture, ISA, Industry Standard Architecture. This is introduced by IBM and headed by Mark Dean. Then ISA was originally an 8-bit computer bus that was later expanded to a 16-bit bus in 1984. When this bus was originally released, it was proprietary bus which allowed only IBM to create peripherals and the actual interface. In 1993, Intel Microsoft that has created the new one, which we call as PNP ISA bus that allowed the computer to automatically detect and step up computer peripherals. Then these are now all compact concepts have come where you don't need to have huge systems. These are the small things that can be there into a graphic port or ESA port or the other things, very small, very compact way we are getting today. So AGP port, accelerator graphics port. Accelerator graphics port connects AGP video cards to a motherboard. These are capable of higher data transfer rate than the normal video cards. Higher means that if you are playing a video game or if you are playing anything very high-end versions, if you are playing, then these things will convert into the transfer the data. Communication networking racer. So this slot integrates some basic functionality on the motherboard needed to implement audio modem and network functions. So this is communications networking. It looks like this. CNR and ACR we call this. These are the again externals. It will get connected, but external whatever you are connecting, this one reads and then gives the inputs to motherboard. Then video electronic standards. These are the ones, video electronic standards, VGA. So USB cable, parallel cable, HDMI cable. These are the different types of ports what we have. Then we have Ethernet audio cable. These are the different types of cables we have, which get connected and transfers the information either from the computer to output devices or from output devices to the computer. Then memory chips, RAM. Yesterday we were learning about the RAM. Dual inline package, single line pin package, single inline memory module. All these are the different types of memory chips that are connected to the computer, to the motherboard. So motherboard contains various memory chips. It's not simple one like only hard short-term memory and secondary memory, but it will have various memory chips, which each one will have its own functionality. So we have already described in detail about all these memory chips in the previous unit. So these memory chips comes under volatile memory RAM chips and non-volatile memory ROM chips. This is the RAM chips and the ROM chips. Can you see them? RAM and ROM. Processors, clock speed, internet, register space, etc. Then your actual back panel of the computer, this is how it looks. From here, the power supply cooling fan will be there, power connector will be there. It is better you note down these points because in the they can ask you what is the back panel, how does it, what are the components it has. So this kind of picture will help you to explain in a much better way. Case cooling fan, then thumb screw parallel port, then mouse connector. See, for each one, this is the mouse connector. I'll expand it. If you can see mouse connector, keyboard connector, they are next to each other. Then serial COM port. Here, those parallel ports. I showed you VGA port, parallel port, USB port, microphone jack,
Mouse
audio
connected.
jack. All those expansions, all the slots, everything will be kept here. So, and front end will look like this for you. You press this button, this will open, you insert your CD drive or floppy disk. This is the floppy drive. This is the memory, memory chip, card slots. This is the button. power button. You can switch on and switch off. That flash fancy lights will be on here when the computer is running. Then future expansion, if you want more slots are given. I told you more slots will be given so that if you want to expand it, you can expand. Here the CD-ROM drive and the floppy drive. CD-ROM and floppy drive are the external memory cards, memory disks. So this is about the model examination questions. Explain the computer cabinets. You have to explain motherboard and its functions, block diagram. SMPS is very important. Then ribbon cables and third-party devices. Okay, this is about the sixth unit. Let me stop sharing and go to seventh unit. Seventh unit we need. I hope all of you are carrying the paper and pen.
Yes, ma'am.
Ma'am, excuse me, ma'am.
1 second.
Ma'am, doubt.
What are you saying?
Ma'am, I have a doubt, ma'am.
Hmm?
I have a doubt, ma'am.
Say.
Once, can you tell about computer block diagram, ma'am?
Block diagram I showed in the beginning, no? You didn't
Means,
understand?
Yes, ma'am, I didn't understand. Once, can you explain again, ma'am?
Yeah, I can. 1 second. The first beginning one or the
Ma'am.
last one?
Ma'am, first row, ma'am, third question, ma'am. Describe the
Block
block
diagram of
diagram of
computer.
computer, ma'am.
Yes. This is the block diagram of computer. This one. Completely block diagram.
Yes,
Motherboard part, if you explain, this is how it functions. Completely everything will be here. Computer, motherboard, block diagram. So here you will have the input output signals. Input output means your mouse, through mouse you give the information, through keyboard you give the information, and through other floppy disk you give the information. All those serial port, it is this part you will get it. Flash ROM BIOS, from where you will get the read only memory. Whatever inputs you are giving, it will read only memory and then put it into the memory slots. Then it goes to the south bridge. There are two bridges, north bridge and south bridge. So in the north bridge, the PCI bus slots will be there. This is the computer concept components, principal components there that will be here. All your motherboard connectors will be kept here. Then external cables and ports will be connected here, right? So south bridge is only connecting part. It just connects everything to one another. Then you will have the high speed graphic bus. This converts the graphics or the information whatever you are giving into the readable part. And this north bridge is having the memory. That means it stores your information, it stores the graphics, it stores the processors, it does the processing of your this thing. You do anything, you want to play a movie, you want to play something, you want to talk something, you want to type, or you want to do any program, all those things will be processed here, right, in the north bridge. And this will always how does it gets the information from south bridge? Whatever information you are giving, it is going to memory slots. Okay, this from this memory slots, it extracts all the information, process the information. Suppose I got some ant biting here, right? So from ant, the second hand, how does it know? It does not know. From here, the information goes to the brain, right? To the north bridge it goes. So from that, it goes to the where it has to act. My right hand will go and do tap. So like that, the information from one this thing to another, and from the memory it retrieves and then process the information. That's how it processes the information. So then this is the front end. This whole part, if you can explain as a mother basic block diagram, that will be more than enough. Any doubt more?
No, ma'am.
Clear, na?
Yes,
So
ma'am. Clear,
try to
ma'am.
draw if, some parts of this, at least the full picture. And if not more also exactly, you don't need to draw. Little part of what are the ports, where are the ports connected. Just put the arrow diagrams, put a rectangle sheet, put the arrow diagrams, where are the connectors, where is the CPU socket, where is the fan, all the slots. This is actually actual picture of the block diagram. But internally, how it works is this block diagram. Clear?
Yes, ma'am.
So now
Ma'am,
let
excuse me, ma'am.
uh,
Ma'am, in
okay.
exam, you should draw this diagram or second diagram,
This
ma'am.
diagram you have to draw.
Okay, ma'am.
This diagram is a must.
Okay, ma'am.
Okay, this diagram one.
Ma'am,
Yes. One is that diagram. If at all they ask for the ports and all, this port, PS port, you have to explain. Then ribbons. Ribbons are there. 1 second, I'll show you the ribbons. Cables, ribbon cables or cables of computer and motherboard, BGA cable, PS2 cable, USB cable, parallel cable, serial cable. These are all called the ribbons. These are the ribbons. Clear, all of you? Small rough
Yes, ma'am.
figure or explain these things, that is more than enough. These all whatever is getting connected to the system. Okay, let's go. I will, time is very less. So I will teach you. 1 second, is it there? 7, there. Units. So 7th chapter is number systems. It's very, very, very important how backend you are giving typing A, B, C, D, X, Y, Z, and anything you are typing, and the system is understanding and is giving you the output. Whatever you want, it is working very fast. But how is it working? What is it happening at the back end? Is the computer understanding NUMBERS? No, it is not understanding. It is understanding only the binary part. Binary part means it is able to understand only 0 and 1. It does not understand more than that. But how is it getting translated? How are we conveying the system to understand that? That's where our processors comes into the picture. The number systems are playing a very big role. One number system is the binary number system. Second one is hexadecimal system. Then octal system. Three types of systems are there. So here, objectives, introduction, logic gates, binary number system, octal number system, hexadecimal number system, and summary. These are the things what we are learning, 6 concepts. Gates, logic gates. What are logic gates? Logic means, suppose you have a door, your front door. Somebody rings the bell. You will open if you feel that person is not going to do any harm to you. You don't open, you close the door because he will harm you. Means it is yes or no to open or not to open, correct? Or so these are the logic gates. When do you use what logic is depending on you, right? So if it is favorable to you, you open. If it is unfavorable to you, you close it. Correct or not? Correct or
Yes,
not?
ma'am. Yes.
Yes. So now what is this logic gates is, for example, I'll go to the logic gate only, which will make it easy for you to understand. Yeah. So now see this input gate. Input, there is an AND gate we call. There are different types of gates. One gate I'll explain you. So what are the actually logic gates? Logic gates are the ones electronically controlled switches. You switch on, it will accept or reject. It will on or it will not on. It will open or not open. So these are called the logic gates, and that implement the Boolean logic process. Boolean means true, false, yes, no, such type of things. Boolean means double, yes, no, true, false, that type of things. The process consists of logical operation on one or more logical inputs, 0 or 1. It gives the answer as 0 or it gives the answer as 1. It generates solitary logic output 0 or 1. So the kind of gates what we have is, first gate we can say AND gate. And gate name is AND. What is this AND? There are two things. A and B are the two inputs what you are giving. What it will understand and take it. AND means this also and that also. Suppose I tell to a small kid, I have a chocolate 5-star, and then I have it, what do you call, silky, some two chocolates. So two chocolates, Nestle, we call, what is that, Nestle? 5-star. One is 5-star and one is Perk something. So two chocolates I hold. I say, which one you want? What is the small girl or small baby say? I want both. This and that. I say, you take only one. Either this or this. So sometimes or, sometimes and. She says, no, I need both. I want both. So both, when will it happen? When 0 and 0, both are 0, then 0 you will get it. And if both are 1, it you will get the answer as 1. If at all, suppose 0 and 1, is there end possible there? No, right? In that case, the answer will become 0. If at all 1 and 0, in that case also the answer will become 0. A and B. Are you understanding?
मैम ए एंड बी का मतलब
ये भी दोनों. ए बी, ए एंड बी दोनों भी चाहिए. दोनों 0 0 है तो आंसर 0 0 होगा. आपको 2 स्टेटमेंट्स है. सपोज फॉर एग्जाम्पल, जाहिद पाशा is a good boy and he is getting good marks. Correct है sentence?
Yes.
Correct na?
Yes.
Zahid Pasha is a good boy and is getting good marks. Correct.
Yes.
Zahid Pasha is a bad boy and is getting a good mark. कुछ ठीक नहीं लग रहा?
No.
नहीं ना? So that time where not a good boy, when I say, not means answer will be 0 na? Both
Yes, ma'am.
both should go together. They're not. Then suppose he is a very good boy but getting very less marks. Being good boy getting less marks also we don't want. Either you should be good boy and good marks, bad boy bad marks, but good boy and good marks is good. Are you getting my point? And whenever we are using, both should be of the same type. Then only and will give you the same answer. Otherwise, both will give you the 0 as the answer. Are you getting me?
Yes, ma'am.
In 10th class, you have learned statements and sets. You remember statements and sets?
Yes, ma'am. We remember.
P and Q. If P is true, Q is also true, the answer is true. If P is false, Q is also false, the answer is false. But P true, Q false, it is not true. Correct, na?
Yes, ma'am.
Yes or no?
Yes, ma'am. Yeah.
Right. So this is AND gate. So understand this gate, AND gates. You will have a question on AND gates. Then I'll go to OR gate. OR gate means this or this. I asked Perk and then 5-star. Anyone, this or this. Zahid Pasha is good or he is rich. Good or rich, fine. Or is fine. Anyone. I need a student who is very good and a student who is very, very intelligent. Good or intelligent, both are different. So, or either one of them. Right? Or when you take any one of them, if it is there, it is enough for us. So 0 0 means 0, but remaining all will give you 1, because either ways 1 will be there. So you can always take what is 1. One of them you are taking it. So you can take always 1. In the previous case, 0 will take. Here we'll take 1. True or false. You choose either any of them. So any of them if you choose, whether you take true, whether you take false, but answer will be true only. It will be correct. So that's called OR gate. Then NOT gate. Not. If I say 0, then NOT gate will give you 1. If I say 1, the NOT gate will say up. We know
Opposite.
If your mother said, don't do this, you will do it, right? So not gate we call. 0 means 1, 1 means 0. That's called not gate. Then we have XOR gate. This is XOR gate means what it does is it takes high voltages as inputs and then works on XOR operation. XOR operation means both together should be, both are 0 means it will give you 0. Both are ones also it will give you 0. But otherwise, if one of them is 1, it will give you 1. Understanding this? All put them together after the class, write all together in one page, then you will understand it better. See carefully AND gate. How is AND gate? We have 3 zeros and 1. If you have both 0, 0, 0 and 1, 0, 1, 0, 0. And both ones is only 1. Both should be 1 and 1 is 1. 1 and 0 means it is not true. So it gives 0. 0 and 1 and. So 0 and 1 means we will say 0. 0 and 0 means 0. Understanding?
We have to draw this tables also, ma'am.
Yes, yes. You have to draw the table and this connection.
Definition also.
Ah. This is definition. This is the figure. This is the table. All the 3 you should draw. Clear?
Okay, ma'am.
Or this or this. That means A or B. A, if not A, then
Ma'am,
B. Hmm?
input and gate means
Muzammil, can you be louder?
input and gate means, ma'am.
I'm unable to understand.
Input
Ah,
and gate means, ma'am.
input is these. A and B are 2 things that are okay. I'll give you. Suppose if you are giving 2 statements to the computer, how does the computer understand? It will, the gate will be there and the input gate, AND gate or gate will be there. AND gate may rose is red and rose is having smell. Both are true. So you will get a true statement.
Yes, ma'am.
Correct. Both are. If both are not correct also, it will be okay. But sometimes any one of them is correct. The figure is the rose, but it is not having any color to that. Then, so both are true is fine, both are false is fine, but not one of them is not accepted in case of AND. In case of AND, we don't want, we will not take, it will be taken as false only, means 0 only. In the case of OR, it will take 1 because 0 or 1. I have 0 rupees or 1 rupee. Which one will you take? 1 only, na? Obviously. Either 0 or 1. So 1. 1 or 0. That means 1. 1 or 1. Anyway, 1 or 1, 1 only. But 0 or 0, what can you take? 0 only. Understanding? Then we have and gate and. So and gate means A, B. You have learned sets. Did you learn sets? Union, intersection.
Yes.
Yes, ma'am.
In okay. I'll show you one small thing. Union.
Ma'am, someone
Suppose
is making noise, ma'am.
this is set A. 1, 2, 3, 4. Set A. You remember union. And set B. Can you see the board? I will write 3, 4, 5, 6. This is set B. Now I write union. That means A union B. If I write A union B, what are the values I take? A or B or both, right? So I'll take 1, I'll take 2, I'll take 3.
4,
Correct?
5, 6.
Yes,
Or
ma'am.
4 or 5
Yes.
or 6. These are the values I take. I didn't take 2 times. I took only once. So here or is used. Suppose I want to take end, that means intersection we call A intersection B. Then I will take end. What is end for both of them? It is only 3.
3 and 4. 4 is also
3 only.
3 and
3,
4.
4. Yeah, 3 and 4.
4.
Yes, 3 and 4. Together, whatever end means both should be there. Same
Yes.
manner, suppose here I say, I will, if I put the table true, false, then true, false means it will give the opposite of it. Both are false means it will give true. 1 true, 1 false means it will give you 1. 1 true, 1 false, it is 1. And 1 is true, but the answer will be 0. Like this, it will give you an AND gate. Understanding? I'll send you some examples so that you can understand better today. Okay. Then NOR gate, that is the same manner. XNOR. I'll take a little bit of tomorrow. In the next class I'll do it with more examples. We have binary system. Yeah. This is the binary system that works on. So binary system, if you have, it will take 0 and 1 into consideration. How does it work with 0 and 1? I hope all of you know the decimal system. What system we use every day in our daily lives? We use decimal system. That means we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits are there. So we use decimal. 10 means decimal system, and decimal system we use. So we use 10 digits and use any number we use in terms of those digits only. 25, 36, 48, 95, 956, 1084. Anything you write, it is all repeating these digits only, digits. Same manner, in binary, we have 0 and 1, only 2 digits, not 10 digits. It is only 2 digits. Any number we will be writing in the binary form. How do we write? For example, 0 and 1 are 0 only. But if I have to write 2, how do I write 2 in binary? There is no 0 and 1, but we don't have 2 number in binary. How do I write that? Then what I do? I will divide 2 by 2. What do you get in the bracket? Here it is 1. And you get the denominator as how much? Reminder, how much? How much?
0.
You get here 2, and you get this thing. Sorry. So what is the reminder you are going to get here?
0.
0. So I will write this 2 as. I'll write this 2 as in the binary system 1, 0. Suppose, for example, that's where I want you to take up in the notebook. Suppose I have a number 3. How do you write 3 in binary system? You divide it by 2. Divide it by 2. Okay, how many times it will go? 1 time.
1.
Correct? Then what will you do? You will get the number here as you put it here. You subtract it by 2. Correct? Yes, no?
Yes, ma'am.
Then you get a reminder as, how much you get the reminder as?
1.
1, correct? 1. You get the reminder 1 na? Now 1 means I cannot take 1. So what will I do? I will put 0 here and I will put 0 here. So I'll get 1, 0 and 1. This is our 101 is our number 3. Are you getting me?
Yes.
Yeah, ma'am.
Right. 4, can you work out with 4? Can you work out? Okay, if by 4, I'll ask you to do 7. Can you work out what 7 in binary numbers? 7. Can you divide? How many times it will go?
3
3 times. 6, then you get one answer. But 3 we don't want. Every time you should divide only 2, 2, 2. 1, 1, 1 only. 1 time, then you will get reminder 2. Again divide, again divide. Every time you should divide with 2. Can you do it once, all of you? I cannot do it here. I thought of getting. I can write. No. 1 second. You hold on. I'll show you 1 minute how to write that. Let me open. Paint. One second. I'll open a new sheet so that I can
110.
explain you clearly from here. 1 second. I'll share the screen. I'll explain you from here. Now, can you see the screen here? So
Yes,
I'll
ma'am.
write
Yes,
7.
ma'am.
I'll put 2. When I divide it by 2, how much I'll get? 3. 2 3s are 6, right? So
Yes,
I'll
ma'am.
get 3. And the remainder, how much I get? 1. Correct or
1.
not?
Yes, sir.
Are you able to see? Then again, I'll divide it by 2. Then I'll get the answer as 2 ones are 2 and the remainder is 1. Again, I'll divide it by 2. I'll get this thing is 0 and the remainder is 1. So 7 can be written as 7 in the decimal form can be written as 1, 1, 1 to base 2. Are you getting me, all of you?
Yes, ma'am.
Right. Same manner. Suppose I have, I'll take one more file. Suppose I have 21. So 21, how do I work? Put it like this. 2. How much 21 means? How much
10.
I should put? 10.
10, madam.
10, na? 2 tens are
Yeah, yeah.
20. So remainder is how much?
1.
1. Then again do 2. How much is the with what number I should divide? 5.
5, ma'am.
5.
Correct. 2 5s are
Remainder
10.
is 1.
Remainder?
1.
1.
How come remainder 1? 2 5s are 10 means there is no remainder. No, remainder is 0.
0.
Yeah, yes, ma'am.
Right. Then again 2. How much?
2, sir.
2
2.
2s are 4. Remainder?
1 remainder. 1.
1. Again 2. How much? 2 ones are 1 time.
1.
Remainder 0.
0.
Every time I should get last, this part should be there. This 0 should come. And the remainder is 1.
1.
Now, let me write 21 to base 10. 21 to base 10 can be written as,
1.
how do you write? From bottom you should go.
Yes.
1,
1.
0, 1, 0, 1, 1, 0, 1, 0, 1. This is to base 2. 21 to base 10 is equal to 21 to base 10. 21 to base 10 is equal to 10101 to base 2. Understand?
Yes, ma'am. Yes, ma'am.
Good. So, some more numbers you work on it so that it will be easy for you to understand the concepts. Let me go to the class 7. Now, in our normal system, we will have the numbers like this. You remember units, lower classes you learned. Units, tens, hundreds, thousands, 10,000, lakhs. Can you tell all those numbers for me in decimal system? Read out. Read out.
Ones,
Units. Tens.
ones, tens, hundreds, thousands,
1,000,
10,000,
10,000,
10,000, 10,000,
lakhs,
lakh, 10 lakhs,
crores,
10 crores.
10
10
crores,
crores,
100
100
crores.
crores.
100
Can
crores.
you read this down number I gave? One big number I wrote. Can you read out this number?
235 crores, 63
Ah.
lakhs, 42,345.
45. Yeah. Now that means all these digits I placed at different, each digit is kept in different location. Based on the location, its value has increased. Suppose 3 is here, it became 30 crores. Getting me? If 3 is here, it is 30 crores. If 3 is here, it is lakhs. If 3 is here, it is 100. Depending, digit is same. Digit is same. But depending
is
on where you are placing that digit, its value is multiplied by that many times. Getting me? Suppose 2.
Yes, ma'am.
2 here, if it is there, it is 1000. But 2 here, it is 200 crores. Into 100 crores, you have to multiply. 2 into 100 crores, the place value made the number increase. Okay, understanding or not?
Yes, ma'am.
So the 10 digits what we have 0, 1, 2, 3, 4 up to 9. These 10 digits can be placed in any of these places so that their value will be different based upon the place where it is going to be. Same manner in the binary system. What can be the place values? Carefully see. This is 1 that is called 2 to the power of 0. Here it is 10 to the power of 0. Here it is 2 to the power of 0. I'll put it as 2 to the power of 0. It's not becoming 2 to the power of 0. 2 to the power of 0. Wait, one second. 2 to the power of 0. Are you getting me? What is 2 to the power of 0? That is nothing but it is 1. Hare Rama. 2 to the power of 0 is nothing but it is 1. 2 to the
1.
power of 1 is nothing but it is 2. 2 to the
2.
power of 2 is 4. 2 to the power
4.
of 3. 2 to the power of 3 means 2 into 2 into 2. 2 to the 4, 4 to the
4
8.
to the
2 to
8.
the power of 3 is 8. 2 to the power of 4. 2 into 2, 4. 2 is the 8. 2 is the 16. You get 16. 2 to the power of 32. 2 to the power of 2, 4, 6, 8, 32. Next 64. Next 128. Next 256. Like that you will get the values. Now I show you how we get the numbers. Okay. Convert. Say who any doubt you have? Any doubt you have?
No, ma'am.
So what I do is this part is half. I'll only binary part I'll teach and leave you. Next class I'll complete the as hexadecimal and octadecimal. Okay. So now in the binary part, a little more time you have to be with me. I'll complete that. So suppose I have this number 10. We have 10. All of you note down in your notebooks 1011001001. And we are converting this into decimal values. And also we are converting one more number into binary form. Okay, both the numbers will do. Let me go to the other whiteboard. Where is it? So right. So you remember one more big number, can you say? Hello?
101100101.
1 second. Let me make this proper. Oh, eraser. Okay. Now, what is our number?
101.
01.
10110101
Hmm.
2.
No, my finger part is not detecting. 1 second. One minute. Let me go to the settings and check that. My finger is not. Somewhere it went off. Just hold on, children. 1 minute.
Okay, ma'am.
Because I don't have that. Now it is coming. So. Okay. So. Let me do one more small number, then we'll go to the conversion part of it. 56 number I want to convert. Can you do it, all of you? And tell me what is the answer for 56? What do you get for 56? How many times it gets divided?
Page number.
28. Answer 28 means 2 into 28 is 56. So the answer is 0 for you, correct? Then again 2. So 28 means
14. 2 14s are,
14.
ma'am.
14 so answer is again 0.
2
Again
7s are.
2.
2 7.
2 sevens answer is again 0.
2
Again
3.
2.
2 3s
2
are.
3s
Answer is 1.
2 3s.
answer is
1.
1.
Remaining is
Again
1.
2. Then again answer is
1.
1, and this also is 1.
1.
Okay. Then again 2, 0. You get the answer as 1. Now from bottom you should write. So 56 to base 10 is equal to 1, 1, 1. 3 ones are there, correct? 1, 1, 1, 0, 0, 0 to base 2. Is it clear for all?
Yes, ma'am.
Yes, ma'am.
Correct? Now, let
Yes,
me
ma'am.
tell you
Yeah.
about the next concept, how to convert back to the digits. So you have 1, 0, 1. You noted down this number, right? 0, 0, 1, 0, 1. Sometimes this is the screen, so I don't know how to write on the screen. So this is how we have. Let's see how to convert. This is in the binary system. I should convert into decimal system. But how many digits are there here? Carefully see. You have units, twos, 4, 8, 16. 16, 32. First note down these names. Units place from left. 2 units place, 2's place, 4's place, 8 place, 16, 32, 64, 128, 256. 2, 3, 4, 5, 6, 7, 8, 9. So I'll put the table.
This is to
What is the
convert into
first number?
decimal
Units
system,
placed.
ma'am.
Pardon?
Decimal system, ma'am. This one converting to decimal system.
Converting into decimal system.
Yes, ma'am.
Second line is 2's place. Third line is 4 place. Right? Correct or not? Then this line is 8. Every time into 2. Whatever number is coming into 2. This is 16. Next number is 32. Next number is 64. Next number is
64.
128.
128.
256. 256.
128.
256, ma'am.
Use this, it's not coming again.
512.
No, this how to cancel that part is not coming.
Eraser option is there, ma'am. Erase or
No, I erased, but after that it is not coming back to same. My finger it is not taking again. When I use erase, it's not taking my eraser only is there, but I have to it should get deselected, right? It's
Yes,
not getting deselected. Not coming. That's where I don't know how to use this part. Okay, I'll use this. 128. Can you see? 128. Then comes 256. Okay. Then you have that much only. Let us see if it works. 0, then 1, 0. By next class, I will learn this how to do it. 1, 1, 0, 1. I hope everything, all the digits has come. 1, 0, 1, 1, 0, 0, 1, 0, 1. All digits have come. Now you make it. First number is 1 into 256. So your first number is 256. Correct? Plus
Yes, ma'am.
0 plus 64. Please add. Plus 32. Are you understanding? Plus 16 means 0 only. 8 also 0. Then 4. Then last number 1. Can you add? Can you add? 256 plus 64. So 256 plus 64 plus 32 plus 4 plus 1. That will give you the decimal value. Did you understand how to do that?
Yes, madam. 357.
Interesting, right? To learn.
366.
How much?
357.
357. Okay, let me check. 256, 64, 32, 4, 1. 5, 6, 7, 17, 1, 11 plus 4. 347. 11. 357. Am I right?
Yes, ma'am. 356.
357.
Yes, ma'am.
Right. So this is 357 to base 10. Understood? Easy? So do some problems like this. The next class we will do a hexadecimal and octadecimal.
Okay,
More
ma'am.
complicated will be there. So be prepared. Okay.
Okay,
I'll check if I can
Thank
take on Saturday. Otherwise on Sunday.
Okay, ma'am.
ma'am.
Okay. Shall we stop the class today?
Okay, ma'am. Thank you.
Thank
Okay,
you,
ma'am.
ma'am.
Okay. Take care.
Thank you,
Thank
ma'am.
you, ma'am.
Take care. Good day. Have a nice week.
Thank you, ma'am.
Okay, ma'am.